Good morning, friends. Myself, Dr. Shantini Bhattacharya, Assistant Professor of EC Department, SRM Institute of Science and Technology, Kattankulam, Chennai. Today, I am going to start a new topic: logic families. Today, I'll cover basically what is meaning of logic families, then its characteristics, then detailed NAND gate, and also CMOS. So, what is logic family? Logic families are different technologies used to build logic gate that perform basic logic operation like AND or NOT, NAND and NOR like that. A group of ICs fabricated for performing various logical functions. It is fabricated using various semiconductor technologies utilizing diodes and transistors as switching components. Now these are basically, now I'll discuss about the characteristics of the logic family. So first of all, the important characteristics is fan in. So what is fan in? It is actually denotes the number of input of the logic gate. So here you can see there is a one example example of fan in is given here. This is, all of you know, this is the symbolic diagram of the XOR gate. So this is actually 3 input XOR gate. So the fan in is here 3. So number of input connected to a logic gate, it is actually defines as fan in. Here also I have given 2 example like that. In a AND gate, if it is a 2 input AND gate, then fan in is 2. If and also for the NOT gate, obviously there is a single input, so the fan in is 1. Now the fan out, that means a number of circuits that a gate can drive. Okay, so you can see in this figure and you can easily understand what is fan out. So this is actually XOR gate representation. This is 2 input XOR gate. So after that you can see the output of the XOR gate actually drive the 4 NOT gate. So the fan out is actually 4. That means the output of the XOR gate drive 4 NOT gate, so fan out is 4. Now coming to the noise immunity, what is really actually noise immunity means how much amount of noise it can actually resist. So noise immunity gauges the capacity of circuit to endure noise or electrical interference without causing a notable deviation in the output. Now coming to the next characteristic, this is called propagation delay, which is very important for any circuits. It is actually the time interval between the application of input and the occurrence of the output. It is actually defines the speed of the circuit. Okay, so shorter the time duration or shorter the propagation delay, that means the circuit is very much speedy, or if the propagation delay is large, then you have to understand that the circuit is very slow, working is very slow. Okay, so now there are 2 terms there it will come. So TPLH, this is, it is a delay time measured when output is changing from logic 0 to logic 1. That means L to high, logic low to high. Okay, and then TPHL, so it is delay time measured when output is changing from logic 1 to logic 0. That means high to low. Okay. Now noise margin, this is another characteristics of the logic families. It is actually represents the amount of noise voltage allowed at the input which doesn't affect the standard output. Now the next topic is TTL NAND gate. So this is actually the diagram of the circuit diagram of the TTL NAND gate, where you can see 3 transistors are basically used. Here all are NPN transistor, and in this case 3 transistor means Q1, Q2, Q3, and in this case Q1 is a multi-emitter transistor here used as an input. Okay. Now VCC is connected to Q1 through R1, this is connected to Q2 through R2, and also Q3 through R3, and Vout at that position we will get the Vout. And this is the truth table of the NAND gate, and all of you know that only when both the inputs, or if there is a multi-input if the NAND gate, then when all the inputs are high, then only we will get the output 0. Otherwise, in any combination, we will get output 1 or high. So just through this circuit diagram, now we will explain to this truth table. Okay, that will actually prove this circuit diagram also follows the same truth table. So first of all, we will concentrate on the Q1 transistor. Okay, so here you can see that this is actually the NPN transistor. So this side is N, this is P, and this side is also N. This is actually, we can replace this as a 2 diode. So this side is connected as input side is N, then this is P, and then again this is P and N, and this P side, that means this base of the transistor of Q1 is connected to VCC. So as P is connected to high voltage, so first of all, when at this P is connected to high voltage, now we will consider, at first we will consider only, we will give 0 voltage at any or logic 0 combination at any voltage. If I consider logic 0, so we can cover this all these combinations, that means 0 0 0 1 1 0. That means at that moment we only consider that any input will be 0. Okay, so if any input will be 0 at that position, if I consider that N is 0 and P is 5 volt, okay, so that means base emitter junction is forward bias and base collector junction is reverse bias. So no current flow through this path, so Q2 goes off. As Q2 goes off, then Q3 also goes off, because the emitter of the Q2 is actually the base of the Q3. So as emitter is off, as Q2 is off, then Q3 also off. Now, but we will get at this condition the output is high. So how output will get high? So here Q2 off, Q3 off, but VCC is connected through this path, through R3, we will get the output V out. So we will get the output, this VCC will come through this path R3 and go to output. So we will get at that condition high the output. Okay. Now just at that moment we will consider all the inputs are 1. So just opposite condition will happen. At that moment the base emitter junction will be reverse bias and base collector junction will be forward bias. So what will happen? Q2 will be on and also Q3 will be on, and so a huge amount of current will flow and it goes in the saturation mode, so output goes low. So this is actually the explanation of the TTL NAND gate. Hope you understand. So if you have any doubt, then give me a question in the comment section. I will try to solve. Okay, then coming to the next part, this is CMOS. CMOS is actually complementary metal oxide semiconductor, is a widely used technology for building integrated circuit including microprocessor, microcontroller, static RAM and digital logic circuits. So what is the construction of this CMOS? CMOS is actually the combination of P-type and N-type MOSFET, and this pairing allows CMOS circuit to consume very less power. So it is very useful to construct any circuit. So now there is some characteristics is also important. Power efficiency, I have already said that it actually consumes less power, so it is rather than any other compared actually logic circuit, so it is very useful. Then CMOS battery. CMOS technology is also employed in computer motherboard, where a small battery helps retain essential system information even the computer goes off. Then speed and density, it allows for a high transistor density on chips, which translate to faster and more complex processors. So these are the characteristics of CMOS. So now thank you so much for watching my video, and keep watching all my videos. If you have any doubt, then give me this doubt in the comment section. I'll try to solve. Thank you so much.